Hello, 12th graders. So we're starting chapter 8, what we're referring to as unit 8. It's chapter 14 in your textbook. So it's actually the very last chapter in your textbook. But we are going to talk about more statistics and different ways to represent data. So I do want you to realize that our previous unit was about univariate data. And we are now going to start talking about bivariate data. So univariate data is what we did last time. Uni meaning one. There was one variable that we were talking about. And while there was an X and a Y axis, I want you to realize that the Y axis was just talking about frequency, right? It was always just about frequency. How many times did this number appear in the course of all of our raw data? So for instance, with univariate, we could be asking about the diameters of apples. And we're just trying to gather information that describes, hence why that unit was called descriptive statistics, gather data that describes a situation that's happening. And so we gathered just one piece of measurement and gathered how many times that measurement occurred. Now, bivariate would be when we're trying to find a correlation between two different things. So going back to the apple diameters, it would be like if we tried to correlate or compare the diameters of apples to the rainfall of that year, or diameters of apples compared to how early the frost was that year. So there's a comparison of two different things where you gather all that data and see whether or not there's a correlation between the two. So we're going to open up this unit talking about scatter diagrams, which we've made before. We're going to talk about patterns that appear in scatter diagrams. And this whole front page are the four different things that you need to talk about in order to describe what's going on in scatter diagrams in order to start interpreting your data. So the first thing I want you to be aware of is univariate versus bivariate data. We are now in bivariate. So this is unit 8. And univariate was unit 7. Okay, so the number one question you should be asking yourself when we're talking about scatter diagrams is there a correlation? So you could always say, is there correlation? We're going to talk a little bit more about this, but correlation does not mean causation. So correlation versus causation, the only thing we can decipher or determine from data that's represented in this way is correlation. Only correlation. If we wanted to go and find anything about causation, you need to create an experiment to determine whether or not one affects the other, where you change what's going on in your x-axis and see if something changes in your y-axis accordingly. That is the only way to determine causation, because you can put any two things in a graph and they might not have anything to do with each other, right? But what we can determine is if there is a correlation between the two variables. We always want to find a model that can help us then take this correlation and use it to predict what an answer might be. And we talk about interpolation versus extrapolation, right? Extrapolation is outside of the data that we've already been given. So for instance, if we had a graph like this, extrapolation would be talking about data that might be appearing over here on the x-axis. So like over here, if that correlation were to continue, we would be talking about something that's happening here outside of our original data. Versus interpolation is you take what's happening inside of our data and then make guesses of things that we don't know about, but we can guess inside of this data. So we use this model to then make predictions, whether it's extrapolation or whether it's interpolation. Okay. A lot of information. Let's just talk about the four different words that we use to describe, or the four different types of words that we use to describe scatter diagrams. And the first one is strength. I do want you to realize, because we'll talk about this in direction at the bottom, but these top guys right here are all a positive correlation because it's going up, as you see, versus all of these guys are a negative correlation as they're sloping down. As x gets bigger, y gets smaller. As x gets bigger, y gets bigger, right? So that's the difference between a positive and a negative correlation. Now you can have a strong correlation. Notice here, it's very tightly grouped around a line. You could have a moderate strength, and you could have a weak one. Now, all of these still have a correlation, right? They all still are trending one way or another. This is still trending upwards, right? This is still trending downwards. But the difference is whether it's really tightly grouped or not. So this is still a correlation, a positive correlation. It's just a weak one, but it still is a positive correlation. Okay, so you can have strength about how grouped they are around a line of best fit. We also have a form. We mostly talk about linear and non-linear. This is your linear, this is a positive linear and a negative linear, but we also then group all of the other non-linears together as just non-linear, but you could also reference it in the model that you might use to predict it. This guy right here would be an exponential graph, as it has that like sloping upward dramatically. Remember also, if it's sloping and it slows down on its slope and kind of tapers off, that is also exponential. It could also be logarithmic because they tend to go hand in hand, but you don't really talk about logarithmic as a model in this class, so we'll just always refer to it as exponential. You could also have a quadratic form, or you could have a sinusoidal form. They're all grouped under nonlinear because typically we talk about linear, but sometimes it's nonlinear and you could have different models that would represent it. This would potentially be sinusoidal. The idea with sinusoidal is that it goes on forever and ever and ever. And maybe in this instance, it only goes on for like a certain amount of time. All right, we also have directional. Directional is only, I take it back. Directional just refers to whether it slopes up or slopes down, right? So you've got a positive association here. Here you've got a negative association. You could also talk about like an exponential having a positive association versus it would be negative, right? So this would be a positive direction versus a negative exponential direction would be like this. Yeah, so you can also have it with exponential and a few other ones, but we normally use it to refer to linear. Let's also talk about no association. Both of these represent no association. I think the hardest one to remember, right? Like that, you could be like, that is obvious that there isn't an association. This one is tricky, and I would assume, I haven't tested anybody on this ever in my life, but I would assume that this one would be tricky to remember, that this is actually no association. And it's the reason why is that no matter what is going on the x-axis, whether you're talking about 0 to 100 hours of sleep, right, this never changes. It's always that. So if you see a line that just goes straight across, that just means that the thing that you're measuring on the y-axis is just always this number. There is no association with anything else. It's just as uninformative as this scattered all over the place diagram. Okay, the last thing I want to talk about is outliers. We know what outliers are. It's the fourth thing that you should discuss about when you're looking at a scatter diagram. It's the data that doesn't fit into a pattern or model that we've already established. This would be a strong to moderate positive linear association. But this outlier right here could really like mess up where you put your line of best fit, for instance. Don't ever just dismiss the outlier. You should always look at data that doesn't conform to what we're talking about. You should always investigate it and say, well, why is that outlier there? That's really interesting to study, right? If this represents a correlation between two things that seem pretty normal, and then there's this one person who falls way out of it, you should go explore like what was going on with that person. Maybe that person is misplaced in a classroom. If this is about like average GPA across the whole school versus grade in a math class, right? So then you could say, well, if they in general have like a low GPA and their grade in math class is pretty low, or if they in general have a high GPA and their math class is pretty high. But then seeing like, okay, well, they normally have like a moderate to low GPA, but they've got a really high score in their math class right now. This is probably indicating that they're not in the right math class. And an outlier that's like way over here would also indicate that they're not in the right math class, right? So you should always, always, always explore the outlier. It gives you some really important information, but it is a piece of data that doesn't fit in with the trend. Okay, so let's practice defining it. And what I would like for you to do, I'm going to give you a list of ways that you could describe this, and I want you to click all of the ones that match this. You definitely wouldn't be choosing both strong and moderate, or both linear and nonlinear. Or both positive and negative, right? So you should be picking one of each kind of type of way to describe it. So I would like for you to go ahead and describe A. I would call this, your book would call this a moderate, negative, linear association. So moderate because it is still very much trending down, and it does tend to group a little bit. It's hard because it feels like this is really zoomed in, and maybe if we zoomed out a little bit more, it would seem more like moderate and less like weak. I would imagine that a lot of you guys put weak, but it is, your book would call this a moderate. Okay, go ahead and go for B. This is a strong, non-linear association. So this is, your book just calls it nonlinear, and then in the book it says maybe sinusoidal, right? So you could say yes, sinusoidal, but really all you need to say is that it's a nonlinear association, and it's fairly strong because it is following that pattern very closely. Go ahead and do C. Remember that with this guy, there is no association because no matter what is going on in the x-axis, that number still just stays the same. So whatever we're trying to compare, there is no relationship between the two. For D, this is another moderate, but in this case, positive linear association. For E, we've got a very strong, your textbook calls it perfect, but we'll just stick to strong, positive, linear association. For this guy, we can see that there's kind of this like weird grouping, but there is really no consistency in how they've been grouped. So this is, again, no association. This is a very strong, negative, linear association. This is a strong, positive, non-linear association. I would call this exponential, right? So it's like tapering off. It is positive because it's going up, and you can use that to describe a non-linear association. Absolutely. Last one. This guy right here is a strong, negative, linear association. So hopefully you feel pretty good about how you would describe it. Words that we use, we always have those for. None of these guys really had outliers, but if they did, we would discuss it as well.